Alright, so the last video was on structs, and this time I believe we get to work with an example program. Finally, so the last one was just pure reading for the most part. It was needed because we need to know to learn about structs, but I am happy to start writing something and getting some experience and experience. Alright, so an example program using structs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We'll start with single variables and then refactor the program until we're using structs instead. Make sense? Let's create a new binary project, yada yada yada. I already have a project open. Let's get it. So start with variables. Let's do, they have width, right? Width 1 equals 30. Let height 1 equal 50, and then we have a print, and they even broke it into another line. That's interesting. Make sure we have that semicolon at the end, and let's start. The area of the rectangle, see if I can type here, rectangle is, put that there, square pixels, comma, and then on this line we can say area, which is a function that we haven't written yet, with 1 and height 1. Alright, and then we write the function area, which is going to take a width, we spelled it out, this is U32, okay, so those are changing up there now, and height, spelled correctly, this is also U32, that changes up there now, and then we're just returning width times height. And we should be able to run this. This looks runnable. Cargo run. And we haven't, oh, because I didn't say what I was returning. 32. Dun, 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 dun. And we have the area of the rectangle is 1,500 square pixels. Okay. So even though listing 5-8, this program works and figures out the area of the rectangle by calculating the area function with each dimension, we can do better. The width and the height are related to each other because together they describe one rectangle. The issue with this code is evident in the signature. We have width and we have height. The area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters. The parameters are related, but that's not expressed anywhere in our program. It would be more readable and more manageable to group width and height together. We've already discussed one way of doing that in the tuple type section of chapter 3 by using tuples. Refactoring using tuples. All right, let's do this. So we're getting rid of this. Cancel. We're getting rid of our individual variables, and we would like to couple these two, height and width, into one variable because that makes more sense. A rectangle is one object. Let rect1 equal a tuple 30 and 50. And now the signature is going to have to change. They called it dimensions. And it is a tuple, U32. Still returning the same thing. Oh, I spelled dimensions wrong. And now we're still returning the same thing relatively. We're using the index 0 times the index 1 of the tuple. And this has to change. And when we print this out, we should get the same answer. Refactored does the same thing. In one way, this program is better. Tuples let us add a bit of structure, and we're now passing just one argument. But in another way, this version is less clear. Tuples don't name their elements, so our calculation has become more confusing because we have to index into the parts of the tuple. It doesn't matter if we mix up width and height for the area calculation, but if we want to draw the rectangle on the screen, it would matter. We would have to keep in mind that width is the tuple index 0 and height is the tuple index 1. If someone else worked on this code, they would have to figure this out and keep it in mind as well. It will be easy to forget or mix up these values and cause errors because we haven't conveyed the meaning of our data in our code. So another refactoring, adding more meaning. We use structs to add meaning by labeling the data. We can transform the tuple we're using into a data type with a name for the whole as well as name for the parts. Oh, so yeah, we can make it into a struct. We put it at the top, just like they did. So now we have a struct rectangle, as long as I can spell it. And the rectangle has two fields, width, U32, and it has height, U32. And now rectangle is going to be equal to, rect1, I should say, is going to be equal to rectangle. And we're going to label this width. And we're going to label this one height. And this is curly brackets. And now this signature has to change because now we're taking in a reference rectangle. And they even change the name. So let's change that to rectangle. A reference to rectangle. And now we can say rectangle width times height. Rectangle dot width times rectangle dot height. Why are you red? Did I do something wrong? Oh, yeah, because it's a reference. They have that here. So now I run this, and we get the same answer. So this time we refactored it. We used a struct which now associates, this is a rectangle. We associate those two values, the height and width, to the rectangle. And each of these fields, which is height and width, now have a proper name. So that when you look at area, you can visually see this is width, this is height. That's good. So here we define a struct and named it rectangle. Inside the curly brackets, we define the fields as width and height, both of which have type U32. Then in main, we created a particular instance of rectangle that has the width of 30 and the height of 50. Our area function is now defined with one parameter, which we've named rectangle, whose type is an immutable borrow of a struct rectangle instance. As mentioned in chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retains its ownership and can continue using rect1, which is the reason we use the ampersand in the function signature and where we call the function. The area function accesses the width and height fields of the rectangle instance. Our function signature for area now says exactly what we mean. Calculate the area of rectangle using the width and height fields. This conveys that the width and height are related to each other, and it gives descriptive names to the values rather than using the tuple index values of 0 and 1. This is a win for clarity. I have to agree, this is much clearer. Alright, adding useful functionality with derived traits. It'll be nice to be able to print an instance of rectangle while we're debugging our program and see the values of all of its fields. That would be very nice, sort of to debug the program. So listing 5-11 tries using the print macro, or print line macro, as we've used in previous chapters. This won't work, however. And print rect, I'll try it. I mean, technically speaking, we still have access to rect, so I can write it here just to see what error this is going to give me. Rect1 is, comma, rect1. Could not compile due to the trait system format display is not implemented for a rectangle, which is what we have here. Okay. When we run this code, we get this error message. The print line macro can do many kinds of formatting, and by default, the curly brackets tell printline to use formatting known as display. Output intended for direct end user consumption. The primitive type we've seen so far implement display by default, because there's only one way you want to show a 1 or any other primitive type to a user. But with a struct, the way printline should format the output is less clear because there are more display possibilities. Make sense? Do you want commas or not? Do you want to print curly brackets? Should all the fields be shown? Due to this ambiguity, Rust doesn't try to guess what you want or what we want, and structs don't have a provided implementation of display. That makes sense. So what they're saying here basically is that given that there are many ways in which we would want to maybe display rectangle, they're not going to try to guess at it. Instead, they're going to make us implement it or do something similar. Let's see. If we continue reading errors, we find this helpful note. Rectangle cannot be formatted with the default formatter. Try using this guy instead if you're using a format string. Okay. I think I'm using that. So let's try the print new line macro call with, now looks like a print this thing. So add this thing into the print statement. Putting the specifier, whatever we're supposed to call this, at the colon and question mark, inside the curly brackets telling print line we want to use an output format called debug. The debug trait enables us to print our struct in a way that is useful for developers so we can see its value while we're debugging our code. Okay, so this is used for debugging purposes. But now we get a new error saying that, well, it does not have the trait debug. Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the annotation, this thing, just before the struct definition. Okay, let's copy that. And so if I put this above the struct, then I can print out debug information. And that worked. It printed out rectangle, struct name, it printed out the fields, and it printed out the values of the fields. Interesting. Now when we run the program, we won't get any errors, and we'll see the following output. Bam! Nice. It's not the prettiest output, but it shows the values of all the fields for the instance, which would definitely help during debugging. When we have larger structs, it is useful to have outputs that's a bit easier to read. In those cases, we can use the, whatever this thing is, instead of debug in the print string. When we use whatever this thing is, styled in the example, the output would look like this. Wait, can I do that now then? Let me try that out. Hashtag Oh, it does do that now. So that's just different formatting for debugging. Okay, noted. Rust has provided a number of traits for us to use with the derive annotation that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We'll cover how to implement those traits with custom behaviors as well as how to create your own traits in Chapter 10. Chapter 10. Okay. Our area function is very specific. It only computes the area of rectangles. It will be helpful to tie this behavior more closely to our rectangle struct because it won't work on any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method defined on our rectangle type. I normally don't do this. I normally just take one section at a time, but I mean, method syntax. No, we have to come back to method syntax. It's just kind of long. This is going to be another video in itself. Alright, stay tuned for part 2, method syntax. Till then, I hope you enjoyed it. Hope it was useful. Peace.